Thank you. There's a lot of people here. That's kind of scary. Hasn't this been a great conference? I've really enjoyed the number of different ideas that have come up and the ways those ideas interact with each other. We were talking about the Internet of Things a little bit earlier, and my take on the Internet of Things was the implications for analytics that would go on, but the notion that that anything exposed to the internet needs to be updated, and nobody really wants to do that. I thought that was really interesting. And in my talk, we're just opening the door on a new technology, and I actually believe that there's a world of unintended consequences that we're only starting to think about. So that was an interesting thing. Okay, this isn't very visual. I've only got a couple of things to show you. So I want you to think about the last time you used your credit card online, the last time you made a payment online. For me, I end up going to Amazon way too often. But you're putting in the same kind of information that you put in on a credit card transaction, and that type of transaction was happening in the 40s, actually. They stamp your name and account number on a little piece of metal, put a little piece of cardboard in the back for your signature. When I was a kid working at a gas station, we had plastic then. I'm not that old. But basically, the transaction that you do on Amazon is fundamentally very similar from something you would have done in the 1940s with what was then the precursor of credit cards. And the important thing about that is it needs to be encrypted, because what you provide is everything needed to charge your account some arbitrary amount of money. So it needs to be encrypted and sent to the merchant, and they send it to their payment processor, and they send it to their bank, who sends it to their credit card company, who sends it to your bank. And each party along the way needs to encrypt it, and by and large they do. And only once in a while, or 100 million accounts stolen. But fundamentally, what you're encrypting and what you're putting into that transaction is very sensitive, because it's the keys to your account. So now, what I'm going to try to do is to introduce and talk about another option. And so I'm going to come back to it and try to introduce one idea at a time. The first idea is going to be the basic transaction. And so what we're going to do is we are going to imagine having a public ledger, so that there are many entries on that ledger, and you have the key for some previous amount that's on that ledger that you were able to spend. That will be identified on the public ledger with a public key. And so what you can do to make a transaction to Amazon is you will ask them, if I'm paying you, I will ask you for a public key to which I should send you a certain amount of money. So I will create a transaction, I will use the public key that you gave me, the amount that you gave me, and I will refer to a previous transaction that had at least that amount, and then give some change to myself. So I'll make my own public key for the change. And that's the basic form of it. Because you are giving me a public key, anybody can see that, and they will on the ledger. Also, because everything is going to be public, we're not going to really want to use our own name. We're going to want to use something that's not easy to understand. So basically, all of these keys are going to look really abstract that are on the public ledger. And then at the end of the transaction, I use a private key that corresponds to the previously published transaction to sign the new transaction, and that will create a transaction that he can spend, and then I'll be able to spend the change. And nothing that is published is private. You keep your private keys, I keep my private keys. Every time you use an account, and the account numbers they don't go on forever. They're used once, and then they go, and the next time you accept money, you give somebody a new public key, because keys are cheap. They're really just big numbers, and they're so big that you can come up with a lot of them. And we're going to get into how you create those keys in a minute. Sorry. Okay, so that is the public key. what I want to do today, I'm going to go through really quickly an introduction to cryptography. Really quick, I just want to give you a sense of how it works and why it works so that you can kind of understand at a gut level that it's not as hokey as it sometimes sounds. How many people have any form of Bitcoin or Ethereum or even a testnet token? Does anybody have any? Okay, so maybe 4 or 5. And so this is starting to be used. And for people who are experts, I apologize in advance because this is going to be really basic. And then we're going to go through the development of the ideas, and we're going to talk about schemes that people have for future plans, and we'll be able to kind of assess what the pros and cons of those are. Okay, so I want to go through just 3, I think, ideas about cryptography, just so that you get a sense of it. And the math, because I've been a programmer for a long time, we won't worry about how long, but I've been a programmer for a long time, and cryptography always seemed mysterious and like the domain of only really super smart people. And so when I kind of started to figure out some of it, and I realized that actually you can understand the basics and they're quite accessible, that was a real eye-opener for me. So I want to hopefully share that insight with you. So, and each of these steps that I'm going to take is small. It's going to be really understandable, I hope. So, first of all, one of the key ideas in cryptography is the idea of irreversible math. And that seems a little bit weird because most of the math that first comes to mind is perfectly reversible. You know, addition and subtraction and multiplication, you can reverse that very easily. If you do division and you get a modulus, that is not easily reversible, but you kind of tend not to think about that because how often do you do that? So reversible math's first thing. How many people are familiar with hash functions? I think a lot of people here should be. Is anybody really uncomfortable with hash functions? Is not familiar at all? Okay. Okay, that's basically most people. So I'm just going to go really quickly through that. They're really fun. It's one of these things. Sometimes programmers have this weakness of algorithms that make you feel smart, and hash functions are one of them. So at any rate, if you have a hash function, you can have anything that goes into it. You'll get something out of it. You will always get the same output if you use the same input. So it's deterministic. That's the first thing. The second thing is it's indistinguishable from random. That's actually important in this case. So if you have 2 outputs, you should not be able to tell the difference between random numbers and the output of the hash function. And it should be difficult to find 2 different inputs that create the same hash. It's inevitable, but it should be difficult. So given that hash function, the next basic idea is the XOR, and I'm going to expect that once again, most people are familiar with XOR, so my summary is going to be super quick. If you take an input and you XOR it with something random looking, you'll get something else random looking. And the magical thing about the XOR is it's like super reversible, because if you take that output and you XOR it against the same random looking thing, you'll get your original input back. And so that, if you can imagine, is really handy for cryptography, because if you can create something that is consistent, that looks random, you XOR it with your input, and now you can send it to somebody. As long as they can create the same random looking input, they can decrypt it. And that's the key to the Diffie-Hellman key exchange. And I'm going to kind of celebrate that a little bit. Does anybody know who won the Turing Award this year? The Turing Award? Nobody. That's disappointing. Diffie and Hellman. I just said it. Okay, Diffie and Hellman won the Turing Award this year. And I'm just going to take a super simplified view of what it is that they invented. Because it's what allows you to share secrets, to encrypt something to somebody you've never shared a secret with before. So here we get to the silly numbers that I had on the screen here a minute ago. I don't know if that's going to wake up. So we have two numbers here. We're going to consider for a moment the universe of numbers between 1 and 8,147. And we are going to consider exponents of 251. So what you're going to do is, who's good at coming up with random numbers? Can you come up with a number between 1 and 8,147?
2,549.
2549? All right. So what we're going to do is we're going to take 251, and you can't read this because it's super small. What was it, 2,541? 549. Okay. So what we're doing is we're taking the number 251 and raising it to the power of 2,549. You probably can't read that. It's a big number. Now, the next step in the Diffie-Hellman key exchange, remember that we were going to consider the universe of numbers between 1 and 8,000. So 549. So that gives us, so what we're going to use is your public key is going to be 7,360. And I'm going to suggest that this algorithm of taking the exponent, 251, to the power of 2,549, and then taking the modulus of that, I'm going to suggest that that is not reversible, because you would have to guess the modulus that shows up here, and you can't get any of the digits wrong, or else it just won't work. Close to is no good. So that's the key to what makes this operation bizarrely simple and yet completely irreversible. So we have his private key is the number that you came up with. The public key that you can tell anybody is 7,360. You can come up with another number like that, and you can calculate a shared secret by using his public key and raising it to your private key, the number that you just imagined. You raise that and then you take the modulus. You can publish your public key. He can take your public key, raise it, and raise it to the power of his private key, 2,000 whatever it was. Then he takes the modulus, 8,147, and he'll get a number between 8,000, and you're both going to have the same number. And any of the rest of us who are intercepting that will not be able to do the calculation because we cannot reverse that calculation there. We can't guess at what his private key is because that's so difficult to reverse. And so that's actually the... And can somebody see the problem with this? What's the problem? Well, that's a problem, true. Yeah. How about another problem? Yes? The key exchange? Yep. That's basically similar to the man in the middle.
But isn't the initially they had to communicate?
Well, that is the expectation of cryptography before this algorithm came up. That you need to share a secret in order to be able to create that randomness that will be consistent between you. And the magic of what Diffie and Hellman did is by taking a private key and raising it to the power of some crazy other number, and then taking a modulus, you can share something, and it's so hard to reverse it that despite the fact that the public key can be seen by anybody, and you need a secure enough connection to actually get it through so you don't have a man in the middle. That's true, that's legitimate. But if you can get it through, then you can calculate a common shared secret, and everybody can see your communication. And so you can now encrypt, but nobody will be able to get your shared secret.
So the thing is, how does the initially, like, let's say it's somebody like you and me.
You both
have to have some way of getting that common shared secret.
Exactly.
Between the two of us.
Yes. You both publish your public keys. In this case, The public key is 70 whatever. I can take that 70 whatever, raise it to my private key. You don't know my private key. You can see the public key, but you can't calculate his private key from that because you can't reverse it. So that's the key to it. And at the time, so it's a very simple trick, but it solves a neat problem. And actually, there are a few things. One other problem you'd have with this is that in this number range, it would be very easy to just. Sorry, what? You just try every number. Exactly. You can try every number. And so the problem we have with these big numbers is that it becomes infeasible. In this case, it was infeasible to reverse. So what you want to do is you want to get a number universe that is so large that it would be difficult to go through all the numbers. So in this case, we solved half of the problem. We didn't have a number space big enough to prevent that. If we're using this scheme in anger, we would use bigger numbers. For me, this was an insight because even with numbers that are semi-manageable, like 8,000, we still get results that are so crazy big that you can really understand how this is not reversible. And then there are a bunch of other problems. I'm going to suggest that what we've covered is kind of the nub of it. Things like man in the middle are important considerations. There are a few other attacks that you have to cover basically by being super careful. Yeah?
I was going to say another problem is it becomes difficult to compute when the numbers get that large.
Yeah.
Reverse it and then...
Yeah. Your computing time gets up, and if you're worried, particularly if you're worried about quantum computing, you start coming up into a scheme where you're using really big numbers, and you actually make life difficult for yourself. Hopefully you're making life super difficult for an attacker, but whatever. At any rate, so we went over some of the basic technology. When Diffie and Hellman came up with this algorithm, they expected that what you would be able to do in the future is have a similar algorithm of similar complexity where you would take a document, take the hash of it, and then do a transformation of similar complexity on that hash, and then that could be validated by using your public key as a signature. And that did happen. And then there was another algorithm that was more complex that came out that's commonly used as the elliptic curve. But the first one actually even took about 8 years. And the funny thing about that is even when you have your hands right around the fact and you have a really good idea that there is a solution, sometimes it actually takes a while for somebody to come up with it. And that's the next step we're going to get into with digital transactions. This kind of a scheme where you have a public ledger and you sign transactions is clearly a more natural fit for the internet. And as such, it's the kind of thing that a lot of people have been trying to do for a long time. Can anybody tell me when the first digital currency was started? Yes. Yes. Many people would say 2008, and that would not actually be correct. David Chaum, I think, was one of the innovators. He came up with a scheme, and he actually sold it to a couple of banks. And what he would do is you'd make an arrangement with your bank. You'd have a number that was kind of semi-public, and you could use it with a certain amount of anonymity, and then they could go back, but it had to go through the bank. Between 1990 and about 2008, there was about 100 other attempts to create a digital currency. And the thing I find interesting about that is I always try to be very careful if a lot of other people, a lot of other smart people have tried a problem and have failed. I should respect that and understand that it's not going to necessarily be easy for me to overcome that. So if you can imagine, like, coming up with, digital currency number 68 when there have been many failures before. And some of these failures are by companies like Visa. Visa had a scheme. Citibank had a scheme that they were trying to put forward, and these did not succeed. So in 2008, we had the paper that initiated Bitcoin. And there's two innovations that I'm going to I'm going to focus on with that. One of them just barely predates that, Hashcash, and that kind of established the structure that Bitcoin ultimately used. With Hashcash, you would take basically the same form of transaction that we talked about already. You basically use digital transaction, digital signatures, and you publish that for a transaction. You take a group of them into a small table, and you take a hash of that. Now the hash of that will be used in a block header. The block header will have that. It will have the hash of the previous block header, and it will have a couple other things. And so each block refers to the previous block, includes a whole bunch of new transactions. And that was the scheme of Hashcash. And it was structurally pretty solid, but it didn't really get started. The thing that Bitcoin added was the idea of adding to that header a random number. Sometimes innovations are oddly simple. You add a random number, and you keep repeating that operation until you get a hash that is below a certain threshold. So it starts with a bunch of zeros or is a smaller number. And what that allows you to do is allows many people to operate the system and work together. And the key there is that it's distributed. It's like the internet. Many people are enabling it. And then in the beginning of the list of transactions, the miner pays himself, so he has incentive, which are pretty small changes to that. But the next step, of course, is the kind of social implications, and that's where actually people who have a good understanding of open source technologies, I think, actually have a huge advantage. I think a lot of people who are looking at this kind of space, it's hard not to approach it with a certain amount of greed, but that's a real thing, and it's also something that you anticipate. If you're looking at somebody putting this, even Citibank, putting forward this digital currency scheme, you kind of expect that they're not going to be very altruistic in how they operate it, or even fair. I mean, if you have any dispute, you don't really know that they're going to be fair. And some people that people don't necessarily remember is the establishment of the New York Stock Exchange was established through the Buttonwood Agreement, which was an agreement between 24 stockbrokers. And the idea is there were enough people that you wouldn't have too much favoritism for one, that they could all believe in the system, and of course they go forward. And an institution that is kind of central to capitalism is an area where we kind of forget that in order to buy in the first place, they had to actually work pretty hard at convincing everybody that the group was going to be fair. And that concept is a real theme here, a real recurring theme. The concept of cultivating a community. And I think actually in this space it may be harder than it would be in most spaces. So there's that. Another thing that is kind of a community level consideration, the idea of open permissionless innovation. When the internet was new, and even today, you can start a web page. You don't really need anybody's significant permission to start it and create some new idea and get it going. And that's a really important concept because it means that people with new ideas who don't have an establishment behind them, don't have to convince some large organization that they're to move their idea forward. They can basically do it themselves, and if they can find other people who are interested in it, they can push it forward. And schemes like the scheme from Citibank were not open. And so this whole idea is not relevant unless many people use it, and unless many people use it for completely new things. One of the features of the basic transaction, is that it's viable for a larger range of values. If you're using a credit card transaction, you're probably spending, the the bottom end of the range might be $10 or thereabouts, might be, the top end might be 1,000. You might use it for more or less, but odds are most of the credit card transactions are in that range. For a digital currency, you could easily see using a tenth of a penny or a hundredth of a penny, and you could probably go to $100,000 now without, because the transaction itself is really cheap. You're just publishing a few bits, and it's quite secure because you don't have to encode something. You don't have to trust a bunch of other parties to keep their security. So the potential range is bigger, and that means that there's an opportunity for a lot of new applications to use that kind of technology. And in order for that to happen, that needs to be allowed. The idea of open, permissionless innovation, of having somebody just come up with an idea and be able to try it out and build something is very important. And so I think going forward, those kind of basic ideas are going to be important. Just before we close, I'm going to talk about a couple of new things and places where people are anticipating new technologies. I'm going to start it, but I'm going to ask you to think about things you want to ask about. First example I'm going to talk about is The Economist magazine, because they were typical of many people who were commenting on the space. Last year they had an article talking about blockchain. And their anticipation of the future was that it would be like Bitcoin, but, and the but was they wanted to get rid of mining, which they saw as wasting electricity, and they wanted to lock it down and have a permissioned access to the system. And that seems reasonable, and it seems reasonable enough that many people agree with them. And have similar ideas that are pushing forward. And I'm going to suggest there are a couple of reasons why that is not viable. For one, there have been 100 people who have tried basically that before and have failed. And when you take away the mining, what you're doing is you're taking away one of the most important pieces of the innovation that actually created the only currency that started to be viable. So if you roll back those innovations, rather than standing on the shoulders of previous innovators, you're starting back where they started. And again, we've heard that before. And so if you kind of look at those ideas and keep that in mind, I think you'll see a lot of the ideas that are coming forward have that kind of problem just inherent in them. Has anybody heard of some other technologies that are adjacent or close that they want to talk about? Yes?
I think what you said is a good analysis, but interesting. Possibly partly counterexample is how successful PayPal is. It's not innovative.
And actually, I think there's a couple of very interesting things about PayPal. I think it's a fascinating example. It started as an attempt to build a digital currency. That didn't work out, and they pivoted. So that's an important thing to remember about PayPal, and that's an important part of starting a business is understanding that your first idea might not work. And they allowed you to have a trust that was less of a leap. If you were going to a vendor that you weren't as familiar with, it was easier to make that leap of faith with PayPal. And so I think that was an important innovation. And also that credit card transaction that I disparaged so much, I don't expect it's going away super soon. So, yes?
Possibly stuff that's distributed computing. I remember reading a few articles about how the community has a push towards bringing stuff like SETI at home and even some of the Fulgent projects into actually rewarding people who are dedicating their compute time with some sort of cryptocurrency or something along that similar line, because again, they're very similar operations.
Yes.
And it's just a way of saying, hey, instead of doing just pure number crunching, you're now actually
And that's a fantastic example, again, on several levels, because a lot of the distributed computing that people are talking about now they're finding that the concept of having a big database server is not necessarily the fastest way to do transactions, even just on a big database. And when they structure it, and it takes a lot of time to figure out how to get a distributed system working, but when you do, you can unleash an amount of power that's stupid. Like, it can be really fast. And then again, there's a project to reward people for coming up with series of prime numbers, prime coin. And that it rewarded people from using their computing power, and they were trying to subvert that in a way that would solve a puzzle, in this case, finding prime number chains. And so you'd get a reward when you did that. And so, again, very innovative. It picks up on a couple of themes, and again, the underlying ideas of connecting, of distributed computing, of trying to connect many peers, has been very powerful, and I think is a theme that we'll see in a lot of different ideas that I don't anticipate, but I know they're out there. Somebody, yes.
So I'd just like your thoughts on like the established merchants. They are not going to just roll over and accept Bitcoin.
Absolutely.
So plus the other thing is the distributed nature of cryptocurrency really doesn't favor their model. And if you look at the law and the legal, so just what your thoughts are on that.
Okay, you had actually like 3 really good things that I will not. One of the things I've been doing is going to the meetups for Blockchain Canada lately, because they're interested in actually finding out what's happening in Canada, like what people are actually doing. And they're trying to ask people in finance and different domains whether or not they're interested in it. And it's kind of funny because you might expect this would be a disruptive technology, and it is. And if you know how disruptive technologies work, you would sort of anticipate that the prime players in the existing industry would probably not lead the new technology. And as much as people at the beginning sort of anticipate that the finance guys will know the most, they've sort of done nothing, or not as much. The people in retail have been finding that people are really interested in maybe doing loyalty programs that would use that kind of technology or whatever. They don't find it threatening, and they're really interested in using some new ideas. So I don't know what will come, but it seems that people who are in the retail industry do find it kind of interesting, and they think that there's some possibilities. Probably because they don't expect to monopolize the financial system, and they're perfectly willing to work in a distributed environment. But we'll have to see where that goes. And then the other thing you asked about that I remember, which may be a subset of the things, legal. And there again, actually, there is quite a bit of interest. There's a lot of lawyers who are commenting on the implications. I think there's 2 or 3 books that have come out. I've read one of them, not the others, so, and I'm not a lawyer, so I can't give any kind of advice. The one book that I read it did frame it in sort of an interesting way, and that is that you can come up with a new technology, but you don't invalidate all existing laws. And so basically, there is already a law against theft. And if you find some way to steal somebody's Bitcoin, you should expect that the existing law is still valid. So you shouldn't expect, and to some extent, it seems a bit like the Wild West, but he went through many of the different implications, and he showed that by and large, it's not the Wild West. The laws do apply. There are likely to be many challenges in applying them in specific cases, and there always are. but it doesn't automatically mean that the rules have disappeared. So I'm going to leave it there. That's really not satisfying. There's a lot further to go. There are actually quite a few lawyers who are quite interested in the space, and there again, that group, those people are very interested, very active in trying to make sure that. One of the other reflections on that is people are interested in creating things like Kickstarter that have a distributed basis, right? And if you use that for something that's basically charitable, then you're probably good. But the legal implications there, the advice that I heard when they were talking about developing a system, I heard some people were developing a Kickstarter-like system. Talk to a lawyer before you before you really establish something. Partly because what they were going to do is they're releasing something on the Ethereum blockchain, and then anybody can use it. And you really want to be careful in how you do that, but it is possible. And yes, you first. Stop.
So one of the things with Bitcoin is anyone can mine it, right?
Yes.
So, however, I'm not too sure on this. There is a limit to how many can be mined as well, and and the more that gets mined, the harder it is for people who mine in the future to discover more, right?
Yes.
So in that case, wouldn't that give an unfair advantage? I'm not sure if unfair is the right word, but essentially those who use the service and mine first, they would get an advantage that people who hop on later may not, want to join because they're already so behind. So
I think your sense on that is totally correct. I bizarrely oversimplified a lot of things. Mining, anybody can. As more people mine, more people, if the puzzle itself was static, it would get easier and easier, and people would find the blocks faster and faster. So the puzzle of, you remember how I said in the block, you have a random number, and you just keep incrementing that number until the hash of the block header is below a certain threshold. So every 2 weeks or so, that threshold is readjusted so that the average time that a block is created is found. And finding just means that you come up with a random number that satisfies the puzzle. That's adjusted. And so every 2 weeks, it's adjusted to keep it about 10 minutes. And so what that means is that as more people put more computing power into the network, it gets harder. The puzzle's difficulty increases, or the number that you have to, threshold below which you have to mine gets harder. So if you have one computer and you've been mining all along, you've gotten fewer and fewer rewards. And at this point, if you're mining with a computer, you're not getting anything. The hash power has gotten to a point where it's crazy. It's really high. And then the other thing there is that the other thing you suggested, and I'm not sure if I'm taking it exactly the way you intended it, but whether it's fair in terms of how rewards are handed out now and historically. And one of the funny things, too, yeah. So right now, there's actually a discrete number of people who have a huge amount of mining power, and so the distributed nature of the Bitcoin system is actually a little bit questionable. Nobody has half the hashing rate, but it's getting to the point where you don't have so many people that it's as fair as it probably ought to be. So that is a very real issue, one that I think is a legitimate topic for a community discussion and a legitimate place where I think you need to have a community and not be careful about. Do you mind if I let him ask first? Okay. Yes?
I think you're addressing my question before I asked
more likely, more than 50% would be controlled by something like 3 or 4, but yeah, we're getting much. Yes?
So, a couple of things. The question of whether it's fair that it's getting harder, I don't think that's a really important one, because it's really a choice. You want to be in the game or not. If you want to be in the game, you have two choices. You can either buy or build the Bitcoin. And that's the equilibrium point. The Bitcoin does not get devalued. In fact, it gets more valuable over time as it's harder to make them and more people want them. And it's assuming that it doesn't collapse because more people don't want it, which is also possible. That's how I understand it. I could be wrong.
Yeah, I think that's fair. I think actually the technology, if we just step back and look at it a little bit more broadly, I think the interesting thing about the technology is how it's sort of at the intersection of technology and finance and art, really. How people interact with this technology is really important, because the only thing that will ever give any of this technology any value is that many people are involved. And I think you're right, there is an equilibrium between just buying it and building it. The issue of a small number of miners having undue influence over the network is a little bit of a relevant issue. As long as that's kind of kept in check, then yeah.
It's a really dangerous one, that one.
Yeah.
Because if they collude, and I'm using a negative word, but it's the right word.
Yes.
If there's a consortium of enough of the miners, they take over governance effectively. I believe.
Yeah.
And when that happens, it's pretty scary to trust it. But if
Sort of. Really what happens though, this technology is so nascent, so young, that it either grows a whole lot or it disappears. And if you're interested in the case where it grows a whole lot, confidence is everything. It's the only thing that's relevant. And so right now, a discrete number of people colluding control the network would shoot themselves in the head, because they give up any opportunity for that really high growth. That's not the only opportunity. The other opportunity for really high growth is other innovations coming along, somebody creating something else. I don't think Ethereum is actually a direct competitor, but something like that, where you have some new space come along, and that just people gravitate to that if they don't believe that the main network is yes.
How big a deal do you think the 10-minute timing is for generating a transaction? Like, because you pay with your good old credit card, you're done.
Sort of.
So, like, I think for a lot of people, if they're just some naive person on the street looking at their options, I can pay this way, this way, this way. I can take cash in my wallet, or I can wait 10 minutes to find out if my transaction's completed with Bitcoin. It's like, why would I ever do that?
Did everybody hear that? Yes, sir?
Yeah, I wouldn't hurt to repeat it.
Oh, okay. The question is about the 10-minute time between blocks. And the reason I want everybody to hear it is it's an interesting one. There are layers on that. First of all, if you're a merchant who's anticipating accepting small transactions, then you should have a node. If you have a node, you have a list of current unspent transaction outputs, and you can check it right away. So you've got a good signature, you know it's a good signature, and you can push it, and you may feel over $2, it's not worth somebody trying to cheat you. Because setting up a cheat is non-trivial exercise. The network is established enough. So if it's a small amount, then you're going to frankly take a risk. If it's a transaction of a house, there's been a few houses sold. I think actually larger transactions at this point would not really be very viable. In the future, it's completely foreseeable, but at this point, that's kind of the upper end, as far as I can tell. You're not going to go on zero transactions. If you're selling a house, you are going to wait for 6 confirmations, and that will take an hour. Now, look at your options there. For a coffee, you complete that transaction right away, and that's fair. And for a house, you wait for an hour. Well, your options, you're going to take that much time anyway. So I'm not saying it's the best for every transaction. I said earlier that I think the current credit card scheme on Amazon it's not going away anytime soon. Like that, it's not taking away anything immediately. But so I'm not trying to prove that it's the best for actually anything really. But I do feel that it's competitive in many domains.
So you put a lot of it back on the merchant or the person accepting the transaction because it's up to them to decide.
Basically, yeah.
Because like somebody accepts my credit card transaction, but I might be using a fake credit card. They're accepting a risk when they do that.
Yes.
So you're accepting a different
And there's
risk you want to accept.
there's these pros and cons in all of the different transaction types. So you're always going to have that. Yes.
We're quite-
Okay, we've got 5 minutes.
I think Litecoin was trying to address some of these issues, where they tried to reduce the transaction time, but then they also tried to use algorithms such that it didn't require, or didn't have an advantage of esoteric hardware such as ASICs and stuff like that, that would concentrate power, so that it would distribute the hashing strength.
I'm going to try to respond to that really quickly so we can get to our last question. Oh, our last 2 questions. Okay. The first thing is Litecoin. It's an important thing to mention. Since Bitcoin was started, there's probably been 700 other, some of them more credible than others. Litecoin was one of the really credible ones that a lot of people latched onto. The thing is that the problem that was mentioned earlier about large-scale mining is one that Litecoin tried to address by having a different algorithm that would be difficult to. Now, the real problem there is that people are willing to design equipment specially configured for processing these transactions. And it's kind of hard to get around that. And in the case of Litecoin, there is some equipment out there that's designed to create Litecoin, and it works much faster than your PC. The effect is much smaller for a couple of reasons, but it's there to a large enough extent that it was a good try, but it didn't really get around the fundamental problem. At the back, yes?
Yeah. What about Bitcoin banks and how some of these banks they amass lots of inflows of Bitcoin and take off and leave?
Absolutely. When Mt. Gox went down, Bitcoin crashed. And the thing is that a lot of people want to kind of get in, but they don't understand it. And so what you should do is you should generate a random public key on your own and get your exchange to put money into your own. People try to find shortcuts and they get around it, and it doesn't always work. And Mt. Gox did not actually undermine the underlying technology. The underlying technology continues to work. But that's never been what has really been as important as the social thing. And it's just complicated enough to get that somehow that has to be addressed. And I don't think it's fully been addressed. But the technology itself is not particularly weak, but that's not really the point. The point is that it has to be socialized. And so we've got an open question there. And was there a question at the top there? Yes?
Yeah, how Bitcoin community is, will it be capable to overcoming this 7 transactions per second limit?
I think you're talking about the scaling limitations in scaling?
Yeah, like you were talking before, that a lot of people who buy a house are willing to wait for several days for confirmation when there's like a hard limit on how many transactions confirmation can be.
Well, that's confirmation. That was his security concern in terms of the time, right? I'm just saying in a big one, you want to make sure that your transaction has been confirmed several times, so it's extremely unlikely to get rolled back. Whereas with a coffee, if you lose a couple of bucks, it's not worth waiting around for an hour to make sure the confirmations come through. But the scaling limitations are real. They're not dissimilar to what we had. The previous example is actually email, when we started adding crazy big attachments like pictures, because it seemed like the email network would have a scaling issue. We kind of do have a similar issue in terms of scaling, in terms of you don't really have that many transactions going through Bitcoin. And there's several technologies. There's an active community. The community is a really important consideration, and that's where I think this group has useful insight. So I'm going to leave it at that, even though it's a bit of a stretch. But there's a lot of work. Like this doesn't really go forward without a great deal of work in terms of addressing the issues that are coming up. So thank you very much.
That's all the time we have, so
Yeah,
thank you,
so-
Warren. Thank you very much.
All right, thank you. Thank you.